Hey guys, welcome back. From this video, I'm going to start the playlist of Java. So in this playlist, I'm not going to discuss about the syntaxes of Java and how to write all these programs in Java, but I'm going to discuss why did we need Java as a language. So uh, firstly, let's try to understand why do we need a programming language in the first place, right? So let's try to answer this question that why do we need a programming language in first place? So as the name suggests, a programming language is supposed to program something. So what does it program? It is going to program a device. So a device, it could be any device, no. To call a device as a computer, it should have a certain things like it should have a CPU, it should have a memory unit, and it should be capable of accepting an input, and it should be capable of producing an output. So let us see this thing here. So this is what this is how we classically define a computing system. So we will have a central processing unit, and then a memory unit, and then there will be some, okay, through some device we can give an input, and through some device we can take the output. So this is normally how we define a computer, right? So even before the programming languages were invented, we did had some sort of a supercomputer. So we had systems which are capable of computing, right? So how do those systems work? Because no, so nothing like any programming language was invented as of then. So then how are they programmed? How did we run these systems? So usually let's understand how these systems work. So the CPU, which is the core program, or we can say the core architecture that is responsible for running all these instructions. So it is going to use the memory called as RAM, the random access memory. uh, okay, a program, a series of CPU instructions. So these are not any statements that you write in program. Initially, they are just a CPU instructions, so which are written in assembly in a pure machine code. So all those instructions will be brought into the RAM, and from the RAM, the CPU is going to execute each of the instructions one by one. So this is how, in the olden days before the programming language was invented. So this is how a processor is used to run. So this is how the computing systems are used to run. But we can see a lot of things wrong with this sort of approach, right? So we have to write each of the instruction, and we have to bring it into the RAM by ourselves. So there is no automatic program that is responsible for making all these things work. Later we invented OS. So our OS has become that sort of program which is used to manage all this instruction execution things. So even though providing each instruction to the RAM is not a great task in the olden days, so they have to provide each instruction in the form of record tapes, or there was something called as punched cards. So they have to went through a lot. So so they have understood that instead of writing each instruction as a assembly code, or as a machine code, they wanted to automate this process of producing a machine level code. So they have invented something called as an assembly language. So assembly language had mnemonics. So using mnemonics, we were able to write the instructions in a easier way, not so readable, but yet it has provided a bit of abstraction. And on the top of assembly, even though in assembly we didn't have loops, we don't have some sort of procedures, we cannot call some sort of statements again and again, and there was no flow control. Yes, there was flow control, but not the way that we use nowadays. So even assembly had limitations. So from assembly, they went on to create something called as a function oriented programming, or a procedural programming. So using the procedural programming, we made sure that we can write a some block of statements called as functions. We can group them together. We can call them multiple times from different programs. We can write conditionals using the if statements, and we can write loops using for loop, while loop, and many. So all these things were embedded into them, and then we're able to create something called as a programming language, which provides all this functionality of looping of and grouping together the statements, and controlling the flow of execution. So all of these things were able to, so we were able to do that using the programming language. So the programming languages are defined into three types. So what we use in our day-to-day life, they are called as high-level languages. So they are more readable to us as a developer. We may find it difficult to write code in this language, but as a computer system, they are very high-level instructions which are very human readable compared to the machine readability, right? And then we have the medium level languages. So we see C, C++, as well as assembly in this mid-level languages. So mid-level languages, they are not exactly the machine code, but they are closer to machine code. And of course, if you look at C and C++, so we can understand that okay, we can understand all those blocks, all those conditionals. We can write programs in C. So it is more of a system friendly and developer friendly. So they sit in the mid-level language, and then we have the low-level language, which we have discussed. So these are the languages which are the closest to the CPU, instructions understood by the CPU, and we can compare them in terms of speed. That low level languages are the fastest, but we don't really use them anyway, because we cannot write all this machine codes and code in binary in those segments. So we try to automate them using the mid-level language. So using mid-level language, so we can automate, so we can produce that a low-level language. So you might feel that okay, if we can automate these things with mid-level languages, then why did we need as something like any high-level language? Because we can still understand C and C++. So C and C++, even though they are okay, we as a developer we can understand them. It is often found that their capabilities are limited because they are so they are supposed to be uh, supposed to be a system friendly, right? So they are supposed to be more of a system oriented programming. So they didn't had some sort of capabilities which we needed to actually develop some sort of applications which are very very high level and more and a more user friendly. So such things were not the actual capabilities of the mid-level language. So we needed to go for something called as a high-level language. So high-level languages, they might use this mid-level languages as an interface to actually create those low-level implementations. So high-level languages are the most okay. So they're on the edge of they're on the edge of the development. So we use these languages to sort of write write programs which are more closer to the real world applications that we use now. So this is the classification of the programming languages. So now let's see what do we have next. So okay, so we have understood that all of these languages. So so we write them in however they are defined. And okay, so why do some languages differ in their syntaxes, and why not a same syntax for every language, and why all of these languages have a different naming structures and a different ways of running them, and a different ways of creating them and using them. So why is this different, and why do we have so many languages? Because we could still have a single low-level language, uh, a single mid-level language, and a single high-level language. So why are there so many varieties of them? So all of this was due to how they are executed in the system. So to execute any of this language, so we need some software which is called as the compiler. The compiler is responsible for actually making that system work. So how does this systems work? So a compiler is going to take the source code It is going to take the source program, and it is going to convert that into the machine code. So that's how, so that's what we have discussed, right? So assembler consumes the machine level code. And, okay, so I could either middle or high. So right in a middle language or the high language, we convert it to that, because actually the local language is what can be understood by the system. So we have to, so okay, so we write code in middle language or the higher language, and it is expected to be converted into a local language. So what is software, or what is the component that is responsible for making this conversion? So is this conversion